The Caribbean region experienced an extraordinary climatic event in the form of Hurricane Melissa, classified as a Category 5 hurricane according to the Saffir-Simpson scale. This event drew widespread attention from experts in climate science, economics, and technology due to its profound impacts on infrastructure, local economies, and technological systems. Hurricane Melissa serves as an ideal case for understanding how natural phenomena interact with modern economic and technological frameworks, as its effects extended beyond meteorological consequences to include digital infrastructure, logistical services, tourism, and commerce, making it highly relevant for researchers and investors alike. Hurricanes form when low-pressure systems develop over warm ocean waters, causing evaporation that rises into the upper atmosphere. As this moist air condenses, dense clouds form, and a low-pressure center begins to rotate, gradually developing into a hurricane. In the case of Melissa, elevated sea surface temperatures in the Caribbean accelerated this process, causing rapid intensification that brought the hurricane to Category 5 status, the highest on the scale. Scientists note that such extreme events are becoming more frequent due to climate change and rising ocean temperatures. The hurricane's force caused extensive damage to Jamaica's infrastructure, severely impacting roads and bridges and isolating several regions from the capital, Kingston. Electricity and water networks suffered significant damage, resulting in widespread service outages for thousands of residents. The effects extended to the tourism sector, a major source of revenue for the island, as numerous hotels and resorts were forced to close, directly affecting tourism income. Tourism represents a substantial portion of Jamaica's GDP, meaning any disruption to this sector has immediate and profound economic consequences, placing additional pressure on the government to provide financial support and implement rapid recovery measures. Other commercial sectors, including manufacturing, warehouses, and markets, were also affected due to partial or total interruptions in transportation and logistics, highlighting the importance of business continuity plans and technical and financial support systems to address sudden natural events. On the technological front, the hurricane caused major disruptions to communication networks and digital systems, with internet and phone services going offline in large areas, halting e-commerce and digital financial transactions and causing temporary data losses in some companies. This highlighted the necessity of developing a more resilient digital infrastructure capable of withstanding natural disasters. The events demonstrated that investing in digital resilience is as crucial as physical preparedness, ensuring institutions can maintain service continuity even during crises. In response to these impacts, the Jamaican government swiftly declared a state of emergency, closing ports and airports to safeguard citizens and deploying rescue and relief teams to provide immediate support to affected areas. Internationally, numerous countries and humanitarian organizations contributed financial and technical aid and provided experts to assist local authorities in damage assessment and reconstruction planning. This international cooperation enhanced the island's capacity to manage the crisis and facilitated the exchange of expertise in disaster management and strategic planning. Preliminary estimates indicate that the economic losses caused by Hurricane Melissa could exceed $1 billion, reflecting the scale of economic and logistical challenges faced by nations vulnerable to strong hurricanes. Experts emphasize the need to invest in early warning systems and weather monitoring while updating infrastructure to better withstand natural disasters, both physically and digitally. Such investments include upgrading electricity and water networks, providing backup power systems, improving transportation and supply chains in coastal regions, and establishing secure and resilient data centers to ensure operational continuity. Additionally, reviewing insurance and financial security policies is vital to protect investors and businesses from sudden losses caused by powerful hurricanes. Hurricane Melissa also illustrates the interconnectedness of economy, technology, and environment, showing how natural phenomena can simultaneously affect financial markets, tourism, e-commerce, and industry. This interconnection makes it essential to adopt multidimensional risk management strategies, encompassing environmental, financial, and technological planning, with a focus on building economic and digital resilience capable of handling extreme conditions. Among the key lessons learned is the importance of integrating rapid response measures with accurate scientific data to allocate resources effectively and strengthen the private sector's role in recovery and reconstruction plans. Furthermore, the hurricane underscores the significance of innovation in climate technology, where intelligent systems and big data analysis can enhance hurricane prediction and monitoring, enabling governments and companies to take proactive measures to minimize damage. For instance, using remote sensing and drones to monitor coastal areas and infrastructure can provide real-time data that informs critical decisions. Developing smart applications for citizen communication during emergencies further enhances response efficiency, reducing risks to lives and property. Reliance on technology alone is insufficient. It must be part of a comprehensive approach that includes continuous human resource training, policy development, and legislation supporting sustainability and climate adaptation. Jamaica's experience with Hurricane Melissa serves as a model for other nations to improve early warning systems, risk management, and continuity of critical services during crises. Integrating scientific knowledge with economic and technological investments enhances the advertising and informational value of content, attracting global interest from companies and investors in energy, technology, and finance sectors. In conclusion, Hurricane Melissa highlights the necessity of balancing science, technology, and economics when confronting natural phenomena. Preparedness and strategic planning are the most effective means of safeguarding lives, protecting the economy, and enhancing community resilience. By learning from this experience, the channel Rala can deliver compelling content that combines precise scientific information with economic and technological analysis, demonstrating how innovation and technology help societies face natural disasters effectively. This case exemplifies how integrated knowledge in climate, economics, and technology can transform natural events into opportunities for sustainable development over the long term.